Hello everyone and welcome to the hands-on demo on AWS X-Ray. So in this demo, we will set up IAM roles for X-Ray integration. We will create Lambda functions with X-Ray tracing. We will configure API gateway with X-Ray tracing. We will deploy a DynamoDB table and enable tracing. We will create a multi-tier application workflow. We will generate traffic and analyze the traces. We will use X-Ray service map to visualize the complete architecture. And finally, we'll clean up all the resources. So this is the complete architecture of this hands-on demo. So here we start with the client. In this case, we'll use the kernel command. First is the API layer, which is this API gateway, and we have a product service API. Then the request goes to the first function, process order function, and that process order function will fetch information about the product from the get product function. So these are the two Lambda functions. Both these Lambda functions as well as API gateway are integrated with X-Ray service. So they will be sending their trace ID. So as soon as the request come here, a trace ID will come here, and when this reaches here and reaches here, the same trace ID will be maintained and tracked, and we can track the performance. And there are some other objects like IAM role for the Lambda execution role. So both the Lambda function will have a role to basically interact with your DynamoDB table and other services like API gateway and CloudWatch and all. So this is the overall architecture of this hands-on demo. So step 1, we'll create IAM roles for X-Ray integration. So I have logged into AWS console home. I am working in US East 1 North Virginia region. I'll search for IAM. I'll click on IAM. I'll go to the roles and create role. This role will be assumed by Lambda. So I will select Lambda service, click on next, and now I will add some permissions policies. So first one is Lambda basic execution role permissions policy, and make sure you select Lambda basic execution roles permissions policy. Next is the AWS X-Ray daemon write access. So copy the permissions policy and select it. Second permissions policy. And third one is DynamoDB, because Lambda will interact with DynamoDB. So I take the name, copy it, and just make sure you select Amazon DynamoDB for full access. Click on next, and then we have to provide a name. So I just call it Lambda X-Ray role. Paste it, and rest all is fine, and you should see your permissions, all 3 permissions. Create role. Click on view role, and now we'll add an inline policy. So basically our Lambda will call another Lambda as per our architecture. So we have to provide an inline policy where it can invoke. So both the Lambda functions, so one of them will call the get product function. So that's why we attach this inline policy. So add permissions, create inline policy, click on JSON, and you can completely replace the whole thing. And click on next. We have to provide the policy name. So I'll just call it Lambda invoke policy. So copy the policy name and click on create policy. So the policy has been created, and now it is already attached to, because we are at the Lambda X-Ray role, and you will see one extra policy customer inline attached. So that concludes our IAM setup. Next, we'll create a DynamoDB table for application data. So next, we have to go to DynamoDB. So I'll open this also in a new tab. I'll just slide it over here next to the slides. And we'll create a table called product catalog, and partition key will be product ID. So partition key is similar to your primary key. Create table, and the partition key product ID. So it will be a simple table with just 2 records and some sample data. And you can just customize settings. You can just go through the settings. So DynamoDB standard, and we have given the bare minimum. And capacity mode is on demand, and you can just check out all the settings but we are just sticking with the default settings. And that's all, and create table. So once the table is created, I will start inserting the records. So we can just go through the what data we have to insert. So these are all the settings. Once the table is created, we will explore table items and add the records. So we'll create item, and this will be our first record. So we are so this is the product ID. This is the partition key. We are giving a product name, price, category, and stock. So there are total 5 columns, and there'll be two records, right? So explore table items. Just collapse it. Create item. You can click on JSON view so that you can just copy paste the whole thing and create item. So this was our first record. And second is this product 002, and that has a stock of 75. So first one has 150, second has 75. We'll just manipulate the stock a bit because we'll make a purchase and it will check whether the item is in stock or not. If the purchase quantity is more than the stock, then it will say, okay, I cannot fulfill your order, right? So these are our 2 records. Moving on, so we'll create a lambda function. So we'll create first lambda function, and that will be called as get product function. So basically this will query DynamoDB and get the record product ID. I'll search for lambda. Open link in a new tab. I'll just slide it next to the slide. And create function. We'll paste the name, and runtime will be Python 311. Architecture is default setting, and make sure you select the default execution role. That's why we created that particular role, lambda X-ray role. Additional configurations, default, and create function. So once the function is created, I'll just dismiss all these pop-ups. You have to go to the configuration and go to the monitoring and operations tools. So here you will have to enable the X-ray tracing. So click on edit. So it already has CloudWatch integration, but X-ray, Lambda services traces. So Lambda service X-ray traces helps you track the path of a request through your application. You can view these traces in the X-ray console. So I don't need now, but I'll just open it. So you just have to select enable. Click on save. So we have enabled the traces, but now we have to provide the Lambda code. So we have seen all these settings. So this is the Lambda code. I'll just walk you through what this code is doing. So first we are importing some important libraries. We are initializing the DynamoDB client, and we are getting a handle to the product catalog table. This is the entry point, Lambda handler. So it gets the event object, the whole JSON. And we are simulating some kind of a delay in our application by doing a process time. It will have a value between 0.1 to 0.5. This I will be using it later, process time, right? And from the event, we have to get the path parameters and the product ID, because this will be posted by a REST based. So there will be a REST call, and the event should have a path parameters and a product ID. So if these things are not there, it will say, okay, the product ID is required. Then we just move on. We extract the product ID from the event. So event. So if you just think of a JSON, like event, JSON object has path parameters. So it's a dictionary, and that has a product ID inside. So we extract it. We'll just print it out. Then we just sleep for this particular process time, 0.1 to 0.5, right? And then we query the DynamoDB table, get the based on the key. So this is the DynamoDB API, the product ID, and we provide our product ID partition key. And whatever response we get, we check whether the item, if the item is not in response, we say product not found. And then we again sleep for 0.1 second. But if the product is found from this whole response, we extract the item, the whole DynamoDB JSON for that product 01 or 02. We convert it to a JSON dumps like string, and we provide back to our HTTP HTTP client, and we say status code, the body. So this is the HTML response body, and the headers like content type application JSON. So this is how you see in curl or any kind of a HTTP client, and some exception handling, right? So this is the whole code. So I'll copy the whole code and go to the function, and I'll paste the complete code, and make sure you click on select deploy. So once you click on deploy, you should get updating the function, and the function got deployed. So this is our first function. Next, we'll create one more function, which is for the process order. So one function has a job of getting the product information. Second, will simulate some kind of a purchase transaction. So this is our second function, process order function. So I just copy the function name. Runtime will be Python same 311 and same architecture, and I will make sure that existing role is selected and additional configurations default. Create function. Next, I have to enable the X-ray tracing for this second function. So I go to monitoring and click on edit under additional monitoring tools. So service traces. So make sure you click enable and click on save. So we have done till here, and next we will have a code for the second Lambda function. So this is the complete code. So again, we start with some imports. Then we have DynamoDB client. We have a Lambda client because this Lambda will call the first Lambda function, and we are getting a handle to the DynamoDB table. So this is the entry point from event, because from the event we have to extract the body because it's a HTML body. So you have response, request, headers and all. So inside body we'll load the body object, and from the body we get the product ID and the quantity. So if they have provided a quantity, we'll extract, otherwise we'll set default it to 1. So if somebody is making a purchase but they have not provided quantity, we'll assume it's a 1. They want to buy one item, and then we'll process the order. If any exception happens in this, we'll have a like status code 400 and invalid request body. So once we have come till this far, we will invoke the Lambda first. We'll have a call to the Lambda function get product function, and we will pass the product ID to get the product details from the first Lambda function. So it will call our Lambda function, and it will get the product detail from the first Lambda function. And once it gets the response payload and the status code is not equal to 200, or sorry, if it is not equal to 200, then we are saying okay, for product not found, and we'll return back the complete HTTP response like body, status code and the headers. But if we have succeeded so far, a JSON load as, so we are converting it to as a string, and response payload body. So we get the whole product information. And now we are so first we'll have a sleep. So again we are simulating some kind of a delay in the application. So this will sleep for 0.2 to 0.6. So it's a random. And now we are checking the stock. So from the product, the whole product, right? So this is coming from DynamoDB, and from the whole product, how much is the stock? So if stock is less than quantity, we can say we don't have sufficient stock. So we send a response back to the front end. So now we are having one more sleep for 0.3 to 0.7, and sometimes we simulate a slow operation. So if it is more than 20, like only 20% of the time, we have a slow operation. We sleep for 2 seconds. We generate the order ID, and finally we'll send the response back to the front end client saying that JSON dump S. So this will be going into the HTTP response. So 200 order ID, product ID, quantity. We'll calculate the total price, like which is product price into quantity and status processing. So this is what the front end will see. And if any error is there, we'll log in the CloudWatch, and we'll say that 500 order processing failed. So this is the complete code. I'll copy the code and go to the code section and paste the whole code and click on deploy. So successfully updated the process order function. So it is now deployed. Okay, next step is step 4, which is to configure API gateway with X-ray tracing. So for this, I have to create an API in API gateway. So I go to the API gateway service. I'll open this in a new tab. I'll just slide it right next to the slides and create an API. REST API. So you have to select this particular option, REST API, and click on build. So this will be a new API and you have to provide all the details. So I'm calling it product service API. And I can provide a description API for product catalog and order processing. So it has a regional endpoint and IPv4 address type, create API. Next, we have to create a resource. So first resource will be the products / products that we want to. So this will create a resource products, and inside products we will have the product ID. So you can provide a product ID and that will get automatically substituted. So once this is selected, I can create resource and provide the product ID like this. Create resource. And once this structure is like this, you have to create a method. And I will say get. And what is the integration type? Lambda function, HTTP, mock, VPC link, AWS service. So in this case, we are selecting Lambda function, Lambda proxy integration, and which Lambda function we want to invoke. So get product function. So proxy integration means sends the request to your Lambda function as a structured event and create method. So this is our first endpoint and this is attached to the backend Lambda function. Next, we'll create one more resource. So for this, you set here and create resource. And this will be our orders for the order processing. So we have created the first part. Now we will create the second resource, orders. So take the value, resource name, orders, create resource, and this orders is selected. And now you can create a method within orders. So this will be a post request Lambda function. It will go to your process order function. So this will post request Lambda function, Lambda proxy integration, and process order function. So 2 endpoints, 2 Lambda functions, and this is how we wire them together. So whole thing is now ready. Next, we have to deploy the API. So come here and deploy API and choose a new stage. So basically a stage will have provide a unique URL and you will know which stage you are testing. So click on deploy. So you will be taken to the stages screen automatically. So just close all the. Okay, once this part is selected, you can under logs and tracing, click on edit. And you just have to select one X-ray tracing. So now this will also be part of X-ray monitoring. So this should be active. So this concludes our setup for Lambda, API and API gateway. Now we'll generate traffic and test the application. So first we'll generate it through the Cloud Shell. So I'll just open Cloud Shell. So I'll open this in a new window and come here, close this. So first I'll just set an environment variable API endpoint. So copy this. Paste it and inside the stages, you'll see this invoke URL. So copy the invoke URL, paste it. So this will set the environment variable API endpoint. So I'm doing a retrieving a product using curl command. So I'm trying to get product 1. So I get the product 1. I can do the same for the second product as well. So I get both the products back. Next, I'm just doing if let's say if the product does not exist, it should give me a valid message. Okay, product not found. So all these requests are going through the API gateway first. An API gateway is using the Lambda function, and Lambda function is fetching the information from the DynamoDB table. And I can do a process order function. So this will go to the process orders API, and this will be in turn handled by the Lambda function, process order function, and it will say okay whether the purchase is successful or not. So it says okay, we have asked for this product 1 for 2 quantity. So it said processing. It has calculated the price and it is processing. What if we want to do an invalid product? So we get the successful message saying that it's not found. So now we'll generate the bulk traffic script where we can have some more data so that X-ray can show more information. So this will be a bash script. So this is just a for loop, and this for loop runs from here to here, right? And it will run for 20 times. For every 20 times, it will either product 1 or 2. So it will just make a request both 1 by 1. So 10 times here, 10 times here, because this will just we are just checking for even or odd. So if it's equal to 0 or not, reminder. And next we are just doing a curl same 20 times with the some random quantity. So this will vary between 1 to 5. So we are just either product 1 or 2. So both 1 by 1. So this product will be either 1 or 2, right? So this will get substituted over here. So we are saying I want to buy product 1 for 1 time, 2 time, 3 time, 4 time, 5 time. Next will be product 2, 1 time, 2 time, 3 time, maybe 5 times. So I'm just buying this product one by one for 20 times, and then I'm making a small delay between the request of 0.5 second. But these two Lambda functions already have the required simulation of kind of an application delay. So what I can do, I will just upload the script from here, like upload file. So this is the test sh script, which is same as what I have showed you. So file was already there. So what I can do, I can first remove the file so that upload gets successful. Upload file. So this was the previous message, and okay, the file got uploaded. I'll just make sure you make it executable, and I can just show you the content which is same as what I've showed you. So now I can run the script. So this will run for this will take around 10 seconds. I have introduced 0.5 second delay because sometimes the service gets unavailable because we are inside free tier. So okay, all the requests got completed. So we have made almost 25 requests by now. Now we'll analyze the traces in X-ray console. So for this, we go to CloudWatch and traces. So I come to the CloudWatch, and this will be under traces. So CloudWatch traces. So if you click on traces, I'll just close everything. So you will see, okay, let me just make it last 15 minutes. And so these are all the requests. Let me just refresh because we have just finished sending all the requests. So this is how you will analyze your traces. So you will see if any error is there, so this there will be trace ID. Let me just go to 30 minutes and you can see all the data. So if I click on first one, there's some error, so it will immediately come to like why this. So if I click here, and you will get more information like which segment. So we call that segment ID or subsegment ID. So this whole trace ID is will be there in all the systems, and what how much time it took, what error, everything you can find out. So for in this case, okay, so the product was not found 404. So from our script, we are also sending some 9 like some product, which for example because we send some invalid product using our testing, right? So those were like 404 product not found, right? So if I go back to the traces and let's say this particular request, right? So this got completed. You will see all okay, and you will see all the segment status okay, response code, how much time it spent in all like process order function, this API, and get product function, how much time it spent. So you can drill down and see which particular segment is slowing down your overall response times. Let me just get more like, because there should be more information, because these are the first 5 requests which I have triggered. So these two are the one which product not found was there, which we have triggered. So 404, and these are the successful ones. So this and you can click on any part, and that will take you to the relevant segment ID section. And here one more thing is like trace map. So trace map, you can see the complete visibility of how your application is structured. Like what happens, like client, it goes to the API gateway, then there is a Lambda context, and then there is a Lambda function. All that information you can see from here. And we have some more feature called as analyze traces, which will take you to the analyze dashboard of the X-ray. So you can click on analyze traces. So this data is taking time to load. Let me just pause the video, and once that info, all the requests that we have fired, I'll be able to show you more information. Right. So after around 5 minutes, I am able to see all the traces that I have fired. So if I just come here, I have to say last 30 minutes, and I want to view all. So I'll just select all. So I'll just say show me 500 traces, and this will the total of 27 traces. So we made 20 requests, and then we made few requests otherwise as well, like ad hoc, and you can see all the information. So that every trace will have a trace ID, and how much time it took, and if you want to drill down and if there is any fault, you can find out. For example, I just picked this one, which is okay, and how this function got all the layers, and inside that, if I just scroll down, you will see, as I talked about, all the stages, and you can click on any stage, how much time it takes in that particular stage. All that information will be visible. And let's say I want to go to something which has failed, so it will give you the whole complete map of your application. And let's say this one is has some fault. So if I just come here, for example, this will be red, and if I click here, so this has some fault. Okay, so maybe service was unavailable for that time for a short duration. So 502, and you can find out all information about each and every trace, and you can also see the logs here. So you can correlate with the logs as well. And if you want, you can click on CloudWatch logs inside. So you can go to the CloudWatch also and check out the logs, which which we can do. But trace will be more for performance improvements. Okay. And now if I go to the analyze traces, for example, the analytical dashboard part of it. So if I come here, trace map, and I'll just click on analyze traces, this will automatically open a new window, and you have the analytics for complete. So you'll go to the analytics section, and you have like 45 requests, and how many were 238. There were 5 which got 502 and 404. So product not found, there were 2. And then you can see how much all the URL which got invoked. So the sum of them were like 999, and how many were get post, all those things you can get the complete picture of your application. And traces is what we have already seen, but traces is the, like, you will go back to the old screen, like this, not old screen, this is a newer screen. But if you go to the here, this will give you all the analytics around your traces. I think that's all from my side. So trace map will show you, so you can, as I talked about, you can click on node and you can get more information like metrics, alerts, what is the latency for all the requests, right? Average. So we have, let's say, for 50 transactions, so we can see how much is the error duration. So you can figure out which component is slowing down your application. If it has a high latency and all, we'll come to know from this. Okay, so that I've covered all this, and finally I'll clean up all the resources. So first I will delete the API in API gateway. So I come to API gateway service, APIs, and click on delete. So this will delete the API. Next we'll delete the process order function. So let me just confirm. Okay, so this is deleted. I'll close this window, and this particular process order function, actions and delete function. And the second function, get product function. So actions, delete, and copy paste, confirm. So both our lambda function is deleted. I'll just close this window and this also. Next I will be deleting the DynamoDB table. So I come here and DynamoDB tables and select the table name and click on delete. So delete all CloudWatch alarms also. So this will delete the table. Next, only one thing is left, which is the lambda X-ray role. So I'm on this screen and I can just directly delete the role. So this will go ahead and delete the role. And that's all. I think this role is got deleted. And yeah, that's all. Thanks for watching.